In a simple case, you put two mirrors very close to each other, so there's like a tiny gap between the two mirrors. And these dudes, Fabry and Perov, figured out that only the wavelength that matches the physical distance of the gap from wavelength perspective goes through, and all the others are bounced back. So like when you pick a guitar string and you have a resonance for a certain frequency, this is exactly what happens optically in that gap.
This week, my guest is Jarkko Antila. Jarkko is the CEO of Kuva Space, a hyperspectral imaging company from Finland. We've covered space-based hyperspectral technology a few times on this show. Let's recap. Satellite imagery senses the reflections of electromagnetic radiation from objects on the Earth. But satellites can image the Earth in a few different ways. Most people associate satellite imagery with what you see in satellite view on Google Maps. This is a multispectral image. The image is captured with sensors that collect information in wide bandwidths of red, green, and blue wavelengths. But because of the coarse nature of the sensing, aka these wide bandwidths, the information may be insufficient. Enter hyperspectral. Hyperspectral imaging goes a step further and captures data across hundreds of wavelengths in narrow spectral bands in the visible and infrared ranges of light. The more bands we capture the image in, the more information we can extract about the target area imaged by the satellite. This enables precise identification of materials, vegetation, and even tank vessels in the open ocean. Every hyperspectral company we've featured on the show takes a unique approach to their technology stack. Pixel focuses on maximizing the number of spectral bands used to scan a target area and extracts as much information as possible. Wyvern uses deployable optics that unfold in orbit to achieve superior ground resolution. But the folks at Kuva Space are taking a different bet. Tunable optics. Tunable optics on satellites are essentially guitar strings that can be tuned in space. A tunable optical filter enables satellites to filter for specific wavelength signature. Each material on Earth has its own unique wavelength signature, so whether we want to identify a ship or a gas leak, we can tune into those exact wavelength signatures. This improves the precision of the image taken because the camera on the satellite knows exactly what to focus on. More on that from Jarkko in this episode. In this episode, we also cover the evolution of Finland's space industry and how Kuva Space emerged from it, and Kuva's innovative divide and conquer approach with their satellite constellations. I really enjoyed this chat with Jarkko. If you're enjoying these episodes, make sure you hit like and subscribe to the show. Now, on to the chat with Jarkko Antila. So welcome, Jarkko. I'm very happy to have you on. I always like to have the guests introduce themselves. So how would you introduce yourself in the context of space?
Yeah, I've been dealing with space for actually just a little while compared to many people who've been in space for the whole of their lives. So, but I was involved with old space earlier in my career, and then I was terrestrial for many years, and then came back. So I kind of started with my career as a researcher developing optical measurement technologies. I was involved with some NASA missions like in the early millennia. But then later, when kind of new space started coming up, there was a satellite project in Finland. There was no Finnish company or university that had ever done a satellite. So a professor at the local university decided that now it's time for Finland to make their first satellite, and the CubeSat standards were coming up. So, they decided that Aalto 1 from Aalto University will be the thing. At that point, I was a team leader at a research center, and we delivered actually the main payload, which was the very first version of the hyperspectral camera technology that we are now using at Kuva Space. So the kind of the new space economy of Finland is coming from that single project, basically.
Wonderful. Before we talk about Kuva Space, tell me about the environment in Finland for setting up a space company.
Yeah, that's a great question. If you go back like like 15 years or so, 10, 15 years, the whole space technology ecosystem was like non-existent. There were like just a few companies who had like really good know-how on the stuff that they did, but it was always like a system, delivering some sort of a subsystem to a larger project run by NASA or ESA. And they were really like established players like the Finnish Meteorological Institute. And they were participating like the Mars mission. And so really like this grand, like old space projects. And there was no small companies at all, and no startups also, like outside space either. Yeah, then this Aalto 1 project happened, which kind of changed a lot of things in Finland. So that has directly or indirectly produced like 4 space companies and helped, form a lot of the ecosystem that we have now. And an organization called Business Finland has been running the Finnish space strategy, and now it's also being kind of updated, and kind of the legal framework has been developing just in the recent years. Like the last 5-6 years has been really booming and very different to what it was before. The VC landscape in Finland has changed dramatically from when I started my first company, Spectral Engines, back in 2000. We were doing hardware, so there were like 3 options in the whole country, like who would invest. Luckily, one of them did invest. So, but now there are, tens of funds in Finland that do this. So that also like helps a lot in developing new companies.
Let's talk about Kuva Space. So when you came in as CEO, what did Kuva Space look like?
Well, it was very small. I was like the sixth person or 7th person. We also had a different name, by the way. So for the most of the history of the company, the name was Reactor Space Lab. Yeah, but when I came in, I saw like the team that was there was, I sometimes have been calling them like the AC/DC of space technology. So it was like, a very small team, but playing very tightly together. So they have done already pretty nice work, and were delivering like commercial stuff to the European Space Agency. So I was like, for me, it was reassuring that, okay, I don't need to kind of worry about the satellite stuff, that's being handled very well. But the company had been existing since 2016, so I joined basically at the end of 2020. At that point, that the team had decided that, okay, now it's time to actually make the shift and concentrate on hyperspectral only, and kind of become a digital service provider instead of selling satellites or building satellites to others. So let's build these satellites in quantities for ourselves and use them as data factories, and then deliver services to customers to fight climate change and those impacts. So in 2020, that decision basically had been made, but the business plans and funding was still open. So actually, that was what I came in to do. And then we formed the new strategy and raised our first VC funding in summer of 21, which is like 5 years after the company had been started. So for the first 5 years,
Wow.
We were not on the VC track at all. So we kind of were. I mean, we were even profitable in 2019. So it's kind of an exceptional new space history.
Yeah, that is always great to hear a company that's profitable, that's growing, that's being smart about using the money, smart about raising money when it needs to. You mentioned something about the large constellation of satellites that eventually Kuva wants to deploy. But I have in my research and notes that maybe one of the first payloads was on the ESA Hera mission that was soon to launch in 2024, has launched in 2024. Was that the first payload ever developed by Kuva?
No, our first satellite was launched in 2018. That's a Hello World satellite though, so that had the second version of the camera technology, which was then tuned to the shortwave infrared. So it was kind of the smallest, the shortwave infrared hyperspectral camera ever put in space by anybody. And then we made 2 missions to European Space Agency, Sunstorm and Cube. So real like scientific mission. So Sunstorm was measuring, well, sunstorms, sun eruptions, and then the cube is a CubeSat that has a very high radio frequency transmitting system that to measure the frequencies through the atmosphere, like how they behave. Like you would call it like a 6G testing satellite, so 75 gigahertz. So those were launched in 21, and now Hera mission was launched just a month ago.
Mm-hmm.
But in between, I guess the most important launch for us was on the Transporter 11, our Hyperfield 1 hyperspectral satellite. So actually, we've had like 5 mission launches so far as a company.
Yeah, let's talk about Hyperfield 1. Right, I'd love to understand the terminology that's described here. What is a in-orbit tunable Fabry-Perot interferometer?
Yeah, that's a good question, and a Fabry-Perot interferometer is essentially a spectral filter. In a simple case, you put 2 mirrors very close to each other, so there's like a tiny gap between 2 mirrors. And these dudes, Fabry and Perot, figured out that in 1890 that only the wavelength that matches the physical distance of the gap from wavelength perspective goes through, and all the others are bounced back, so all the others are reflected.
So it's partially transparent to certain wavelengths of light.
Yes, wow. Exactly. So it's mostly reflecting stuff back, but then it lets through a few wavelengths that happen to match the resonance order of the gap. So like when you pick a guitar string and you have a resonance for a certain frequency, this is exactly what happens optically in that gap.
Wow.
And when you apply it in a practical world and you have a means of tuning the gap, then you can tune the wavelength, kind of the frequency of the guitar, or the higher or lower pitch. So it's a little similar thing. So when you then scan the gap, you can scan the wavelength.
Yeah, and you're essentially
then
shortening
then it becomes a spectrometer.
So this is like the key thing you're varying, right? This is how you tune the mechanism. So does that help Kuva Space and your technology adapt quickly to varying demands of, say, the hyperspectral image that you are tasked to take?
Yeah, it's if you look at like why is there not more hyperspectral capacity out there now? I mean, it's the benefits of theoretical hyperspectral benefits are pretty clear on managing different bioresources and chemical spills and mining and whatnot. But for some reason, it's still in early phase. And the reason is that the camera technology is really difficult to make so that it would actually produce good enough hyperspectral images. So you can make hyperspectral cameras that produce signal which is very noisy, but that's kind of like Hyperion 1, the first really a real hyperspectral instrument that was up there. Yeah, so that demonstrated hyperspectral capabilities quite nicely, but it was also noted that the signal to noise ratio, so the signal level versus like how noisy the signal is, was too low for like real application. Still, currently, if you look at like hyperspectral instrumentation, it's actually quite difficult to get past that performance level of Hyperion 1, especially when you make small satellites. When you're a little bit bigger, like Nmap and Prisma, they have a little bit better performance, of course, nowadays. But then when you go to like smaller satellites that you can afford to deploy in multiples, then it's more difficult. Generally, if you look at what the hyperspectral instrumentation now is, that they tend to be these like Swiss Army knives that can basically theoretically do many things, but in reality, the signals are often so noisy that you cannot like automate this system, and then you end up with a single hyperspectral image with a little bit noise, and you need those PhDs to stare at the image for some time to try to figure something out of it. But the real power of hyperspectral is coming from the fact that you can train machine learning algorithms to dig out the insights from that image or from the hybrid cube efficiently, and you cannot do that if your like signal level is too low compared to the compared to the noise. When you have like all the competing systems and all the systems that we know of otherwise have these kind of fixed parameters that they have these fixed wavelengths and then they sweep over with the line scanning system. You end up with the sort of constant fixed amount of signal to noise ratio, which doesn't change much. But in our case, so that's where the difference is coming from. That we can do this full sweep. We end up maybe in a better similar or maybe a little bit better situation. But what we can then do is that if we see an application that we want to concentrate on, and this can be automated as well, we can select only those wavelength bands that matter. And often, if you look at any application, they rarely need 400.
Mm-hmm.
Often you need 5 to 15. So the need is a multispectral satellite, which can be tuned to specific applications. If you make a multispectral satellite for a single application by hardware, you can't do anything else with it. With hyperspectral, you can do many things, so and so, but not really commercialized. So what we can do is that we can take the hyperspectral and we can tune it to all the applications that we need one by one, and the same, and all the satellites have that same capability. So if we have, say, 100 satellites, 80 of them can do this sort of baseline scanning and different kind of change detection and sniffing around. If there's like a weak signal of like methane, for example, here, and hey, there's a weak signal of methane, we're not really sure. Let's tell the next satellite that, hey, please concentrate only on the 5 methane bands that matter, and stare at that place for a while, because we also have a 2D image and not a line scanning image, so we can stop the image from moving and gather more information by factor of 50 compared to our normal location or normal setup. And then after that satellite goes back into the baseline mode and continues scanning. So it's like this fully sort of dynamic constellation that is doing this application optimized scanning that depends on like the customers and the applications.
Yeah, this two-pronged.
If that makes sense.
No, it absolutely does. I think that's a great way to manage and trade so many different options. I'm just curious, from like a business standpoint, from a commerce standpoint, how do you trade what bands to what resolution to select ultimately?
So we are concentrating maybe a little bit more to the signal to noise ratio aspect, like technically speaking, than ground resolution and also coverage at the same time. So we want to cover large areas very reliably. And so that is kind of the theme. So instead of like doing manual tasking of the satellite per request of somebody, a customer knows a place that they want to have some measurement, and they would like call us or maybe do something else, and we would task our satellite and take that information and provide it to them. We see that business model very cumbersome and quite sort of old-fashioned and a little manual. And the problem with that especially is that if you only have tasking satellites, then those satellites cannot do anything else than that tasking. So what you end up with is that you have to ask for a rather high price for each image to ever pay off that satellite. So what you end up with is a pretty expensive tasking system, and that is not like the solution for creating this global high impact, where you need kind of to solve the 3 main problems, which is the accessibility of information, like from price perspective, from understanding what the data is, so getting information, decision hyperspectral images, and then the reach like everywhere as fast as possible. So we kind of want to solve those 3 problems, and this tasking model doesn't really apply to that. So what we want to do is that we want to cover vast areas and do automated insight calculations like continuously, so that the customer can, if they want to know like a yield forecast of wheat in the country or whatever area, then they can sign up to our service and get that information without ever buying any images or anything like this. So that is the kind of the direction where we see us going. And also we want to do it we want to drive the business to a level where the price would be less of an obstacle for like new markets to start adopting Earth observation information. So make it easy, make it low cost enough, and make it available all the time. So that is kind of the business logic why we do what we do.
Yeah.
But you cannot automate these global things without high quality data. And so we would need to have high quality data to automate. Then that kind of unlocks all this stuff.
Yeah. Is this Kuva's actionable intelligence model that's on your website?
Exactly, yeah.
I think correct me if I'm wrong, you mentioned that you decide what images to take and then you apply analysis to them and then provide some sort of actionable intelligence. Is that the
Yeah, so when we don't have the full constellation, the full service yet, there's of course like a path to it. So in the beginning, we have a more limited amount of applications, more limited amount of geographical areas, more limited amount of revisits. And then we are working with like large businesses and governmental customers to both like co-develop these applications, but also like, of course, being kind of the first customers. So it starts more from a tailoring side. But the more applications and the more ground data we gather and the more services we have up and running, the more we can offer that then and expand that to global scale, the more we can then add these sort of, in a way, standard licenses where the offering that we have already contains what the customer, for example, in the agri sector wants. So it will be kind of less and less, in a way, tailoring and co-developing with the customers that we have. And less tasking. So it's kind of a system that is continuously learning and developing and becoming better and more extensive as we get more satellites up and more insights and more data.
Yeah, Kuva talks a lot about wanting to be more transparent with all of this data, as in be transparent with how the inputs go into the system and then the outputs come out. What is that part of Kuva's mission there?
Yeah, it's also a relevant business part. It's not only like an ethical topic, but there are like many businesses where if you are providing some insights and you are doing that through like a black box AI model that's just produced something, it's quite difficult to believe that. You say 92% and the customer's like, how do you actually know that from?
Yeah.
I can't see it. I just see a yellow picture here. How did you know that it's like 92%, certainty that it's like wheat at this growth stage? So you need to be able to kind of maybe like not open the algorithms like completely to everybody, but to explain the principles, how it works, and that there's a connection to the physical world. So that's the kind of the explainability, how we kind of refer it to. And also one part of that is that we have this tunable spectral system that when our algorithms start learning that, okay, these are the important things, around this area, then we can also tune the satellite if we don't have any other applications going on at that area to concentrate on those specific like wavelength areas more than the others. So we can improve even further the measurement capability, but it's not like a random way of doing that, but it's part of this kind of explainability. So we can say that, hey, these are the physiological phenomena that we have in the plants, and that's why we are kind of concentrating on these wavelengths. So it's kind of coming from connecting the physics explainability with the AI, and so for some businesses it's imperative, so they don't like. They will not become our customers if we just give them numbers and ask them to hope for the best.
Yeah.
And naturally, we also want to be a neutral third party in some applications. If we think of things like carbon credit verification or any other kind of ESG reporting where neutral third-party information is needed on what's actually going on. That's another reason why we want to be transparent, that we are trustworthy also in that sense.
Yeah. I think Arvind talks a lot about this black box problem. So very happy to hear that, you want to explain this from first principles. Again, like you said, not opening up the algorithm, but just like explain it from first principles from a physics-based standpoint. What does this even mean? So that's great to hear. So final few questions here for you. What is the VC funding environment like in Finland today?
Yeah, it's actually a good question. It's really thriving. I mean, we have one of the world's biggest startup events actually coming up at Slush in just a couple of weeks. So there's a lot of vibe going on already for that, and it's been like going up a lot. But I guess that the typical thing for the Finnish landscape is that it's very much concentrated on early phase investments. So quite often the track goes that it's rather easy, relatively speaking, to set up a company. And if you have a good team and you have a good idea to get funding in the seed, pre-seed, seed. So there's a lot of funds that are looking at that area. But the funds are pretty small overall. I mean, there's a bunch of it, but you rarely go past 100 million in fund size. So it's typically like some tens of millions, maybe between 50 to 100. From that fund, they need to fund 10, 20 companies over their lifetime. So it's like actually not like a big ticket per company. That's the Finnish VCs typically are like very early stage investors. And so for a company, then it's quite imperative to also attract at some point foreign funds because they are bigger and can kind of take you further on your way to growth. That whole situation is changing a little bit now in Finland. So there's like new, bigger funds coming up, but quite typically has been so that it's rather easy to set up a company, establish yourself. I mean, Finland is a great ecosystem and atmosphere and environment to run a company, and there's like a lot of talent and stuff like this. And then when you get big enough, then you get a lot of funding opportunities again. But there's this like a little missing gap somewhere from A to B ish, between A to C round, which is a little bit weaker currently in Finland. And there definitely like the foreign funds are typically coming in.
It's very exciting to see just, this more funding environments for as more of these new space companies come up. But what are your general thoughts about Starship? Do you think for hyperspectral satellites, there's a need for a Starship-sized vehicle?
Well, we are planning to deploy like a fleet of 100 satellites, or maybe even more in the future, we do need quite a bit of capacity, and the launches, even though they are not like old space priced anymore, but still they are a significant cost item. Then so naturally, if Starship works and there, this whole dream of getting like 100 times or 10 times more stuff up at the same time is coming to truth. That is definitely a needed thing. And if it's going to be groundbreaking, I'm not sure about that. I mean, of course, if the prices go down to like $10 per kilogram or something like this, then you can send up whatever. But I'm not sure if that's good. That's a good thing either. But yeah, absolutely, like getting more capacity up there to have more monitoring capabilities. The price there is an issue. The bigger issue is the timing and when to get up there. Even though SpaceX is have this transport and mission is like 4 times a year, it's still there pretty booked, and it's still a little bit difficult. So all these like new small rocket or small launch service providers are also like a welcome piece of the puzzle, and the whole whole ecosystem in the Western world is depending on like a single company currently to get up there. So it's kind of a risky thing for the whole business in a sense.
In terms of both price and availability, there's definitely still a little bit of a bottleneck in the launch world. Okay, so what advice do you have for founders then in Like having found a lot of companies, working at, being the CEO of a prominent startup in Finland, what is your advice for founders today building either space hardware or space software?
Well, my first advice is always just that, like Nike says, that just do it. that take the step and start. That's step one. Don't over. Even though space is it's a long-term endeavor typically. So be resilient. Try if possible. Try to get the long-term early stage funding. VCs that you talk to need to understand that space is slow. And also, like your own mental health perspective, it's good to understand that lean new space means like 2 years, periods, not 2 weeks. So
Yeah.
everything is pretty slow. The supply chains are not working great throughout the whole value chain. Especially if you are building something, you might end up waiting for some parts for a year.
Yeah.
So you need to kind of prepare for that. So, but of course, as a startup, you might be the one who's solving some of these problems too. But it's good to interview people if you are new to a new space or space in general, to interview people who are there and kind of figure out the generic hurdles and problems that you are more prepared when you are kind of starting at, okay, this is something that I need to consider doing. So that kind of gets you started quite well. Of course, like the business models and the customer stuff needs to be known, but that's for any startup. So it's no different in space. Maybe there's some subtleties in space, like these governmental defense programs are still definitely, unfortunately, the governing factor when it comes to like where the revenue for the whole industry is coming from. So I definitely welcome new space industry companies that are not concentrating on defense, but actually like making the world better also from fighting climate change and improving food security. So that's where we are coming from. And even though we are now also working towards a safer planet from defense perspective, it was not really on our agenda when we have started the company. So that's like the side where I definitely welcome like new founders to concentrate on.
Yeah, that's a wonderful answer. Okay, my final 2 mini questions for you. Every space founder that I talk to, they have a contrarian bet. And I think contrarian bets are really important. They help you. And if the person is right with the contrarian bet, I think that's a big impact, a big positive impact for the space economy as a whole. Now, you're taking a contrarian bet with Kuva Space. Do you have any other contrarian bets you're seeing that you're very excited about?
Yeah, I don't know. I mean, if somebody would have said to me like at that stage that let's reuse rockets, I wouldn't have called it dumb myself. But maybe I don't know that much about rockets or the rocket design. But I mean, it's like things that don't seem like that easy to do now. But many of these things are probably is not that possible at all. But like this in orbit services, that whole kind of ecosystem is actually pretty interesting. For me now, it sounds like, okay, you have like a refueling station up there, or even changing some parts or something, and everything's doing so. Plug in your satellite and recharge it, and go to some other place, or recharge by having like concentrating solar energy in space. So I think like all those kinds of things, like this automated in-orbit ecosystem is something that right now feels like, okay, it's a risky bet that you make it actually work with all the debris and everything also like increasing. But if it does, then it will definitely change quite a bit of how spacecrafts and satellites and missions are planned. If you can plan them to be, in a way modular and upgradable in space, and all that stuff, and data centers in space is one part of that okay, you don't ever like bring that raw data down to Earth at all, but you just you have data centers up there, then you do all the crunching, and you just send out the information, so you don't need to do all the edge computing in your satellite, because you need to gather raw data sometimes as well. But you don't need to send it down because it's in space. So I would say that whole in orbit ecosystem for me is this kind of a thing that I believe that it's going to evolve a lot, but it's still way to go.
I love Lumen Orbit's idea. I checked out their white paper, so it seems very promising if it works out. Okay, my final question to you. If you were going on a Starship tomorrow, what is the one thing you're taking with you to space?
If food is included, like by default, that's I would probably bring my kid.
Okay, great answer. Yeah, that'll be a great experience, ride of a lifetime. Oh, cool. Well, Jarkko, thank you so much for the conversation.